area of cross section, let it be same. I want to replace these two rods with an equivalent rod. Oh, this is A1, A2. Area of cross section of this A1 plus A2. So what thermal power it was flowing earlier, the same thermal power should flow across this rod. Then you can say this is the equivalent of that. H1, H2, here H. Length will be same. Okay, now these two rods are involved in flow of heat. A part of heat current will pass through here. The remaining will pass through here. I think this is like if a water is coming. So some amount of water will split here. Some remaining amount of water will flow through here. No? So when that heat current will split up or when the thermal power will split up, then the rods are said to be in parallel. Okay, these two rods are involved in transfer of heat between source and sink. Now, when I can say this is equivalent of these two, for the same temperature difference, what thermal power together these two are transferring, if the same amount of thermal power is transferred by this, then can you say that this is equivalent of this? This is definitely equivalent of this. Able to think on this one? This is equivalent of these two. So therefore now, so what is the basic condition now? The H should be equal to H1 plus H2. So what is H looking at this? Temperature difference T1 minus T2 by thermal resistance. What is H1? T1 minus T2 by R1. By R2. So 1 by R equal to 1 by R1 plus 1 by R2. What is further R? We can write it as L K A1 plus A2. This will be K1 A1 by L. K2 A2 by L. Thermal resistance. So therefore, what is K is equal to? K1 A1 K2 A2 by A1 plus A2. This is effective thermal conductivity. Then what I should do? I should replace this rod with a material whose thermal conductivity will be equal to K. So what is use of this? Suppose that this will cost you around 300 rupees, 400 rupees. I want to replace these two rods by one equivalent rod. I'll find out the effective K. Then what I do is like I'll go and search the cost of this material. If it is really very cheap, only 100 rupees. This is 300, 400, 700. This is only 100. Better let me replace these two with this one. No? Equivalent. So like this, what happened in the designing stage, what happened? They will go for assuming things. But when they go for practical implementation, no, they'll go for the equivalent where they can reduce the cost, minimize the cost. Okay, this is when the rods in parallel, the effective resistance. So this will be R is equal to what you can write, R1, R2. I think this is a very popular, you know, in Ohm's law series parallel. The same thing is what applied here. Okay, now let's go this one. Suppose if there are two rods, they're in parallel and thermal power flows or the heat current is flowing here. So what will happen? A part of heat current will branch here, H1 and H2 like this. Again, the same H will emerge out. Now, what is the temperature difference? Will be delta T. Both are at same temperature difference. They are said to be in parallel. So what do you mean by parallel? If an thermal power, if it encounters a junction and where it will branch, then these two are said to be in parallel. They are said to be in parallel. Then I'm interested this H1, H2 in terms of H and R1, R2. So I'll take help of this one. H1 is equal to, so first the equivalent, let me write it. So what is H is equal to? Delta T by R. So what is H1 equal to? Delta T by R1. So delta T, what I can write it as? H into R. Substituting this now, delta T is equal to HR by R1. What is in fact R by R1? Okay, what is R is equal to? R1 R2 by R1 plus R2. Similarly, what is H2 is equal to? H2 what we can write? Delta T HR by R2. Solving this will end up. What is H1? Heat current in the rod 1. What is H2? Heat current in the rod, in the second rod of thermal resistance R2 here. So if you know the thermal power, if you know heat current, main branch current, then how to calculate the heat current in the sub branches? Directly we use this particular formula. No need to write other things. No need to use any other alternative method. So directly we can take help of this one. Okay, there's a basic idea of the parallel. Okay, it's the same series parallel what we studied. No, the same ideas are being applied here. Any doubt till now? If you have, you can ask me. Sure. Okay, no, I'll scroll down then. Okay, let's take there are